Hey Kayla, welcome to class today. Hope you get feeling better, buddy, and we are definitely here to help you. So, let's take a look here. Here's the review sheet, Caleb, if you want to write it down. I'm going to bring that by your house later today along with the test. So, either way, there it is if you want to look at this. We're going to start off, Caleb, doing these four first right here, 59, 60, 61, and 62. Those are the ones that Matthew wanted to start with. So, here we go. Okay, number 59. Matthew, Caleb, we're going to condense this. And so here's the problem. And let's go ahead and get started. Now, first of all, men, you never want to combine logarithms that are being added or subtracted if there's a number to the left. So this 3 right here, Matthew, I'm going to move it right here. This 4 right here, I'm going to move it right here. And this 1/2 right here, Caleb, I'm going to move it to the z. Okay? So now, look at the logarithms. Do any of the logs have anything to the left of them? No. Do all the logs have the same base? Yes. And so my suggestion to you is always start with the subtraction ones first. I've always recommended that to you guys. And so, Matthew, I'm going to set this up here, so please be careful. Don't knock that off. Thanks. Right, so exactly. So Caleb, we notice these two logarithms are being subtracted. Now, Matthew, Caleb, look guys, I mean if this would have been a plus sign here, and this would have been a minus sign right here, then I would have done these two first. Because those are the division ones, they're the most difficult. So start with the minus signs first. So these two logarithms are being subtracted, so you take these two logarithms here, and you put 1 log. And then you take your arguments and you divide them and then bring down everything else. So you have plus log base b of z to the 1/2. Okay? Now, these two logarithms have nothing to the left. They have the same base. So you can take these two logarithms. You can write 1 logarithm. And notice these logarithms are being added, so you multiply their arguments. And really you can put z to the 1/2 over 1. So you have x cubed y to the 4th times this fraction over here, so your final answer would be x cubed z to the 1/2 all over y to the 4th. And this right here is your entire argument. Okay? Matthew, what do you think? Step 1, make sure there's nothing to the left of each logarithm. Step 2, make sure all the logarithms have the same base, which they will. I'm not going to try to trick you there. In step 3, start with your subtracting logarithms first. Okay, this is like a doozy here. Let's have some fun with this. Okay, here we go. We're going to condense this down to 1 logarithm, or at least we're going to die trying, one of the two. So here we go. All right. Okay. I see nothing to the left of this logarithm, nothing to the left of this logarithm, nothing to the left of this logarithm, and they all have a base e. I do see 2 logarithms that are being subtracted right here, so I'm going to start with those 2 logarithms there. Now, Matthew, I know you're still copying the problem down, but that's okay. I'm going to go ahead and do this. I'm going to take my first 2 logarithms and write 1 log, and then divide my arguments. Okay? Makes sense, Matthew? Now, I know that really you guys should start seeing this by now. You really should. When I see x cubed minus 8, I'm thinking factor. When I see x squared plus 2x plus 4, I'm thinking factor. Because you can simplify this fraction. Okay, so if you remember x cubed minus 8, you know the cube root of x cubed and you know the cube root of 8. So whenever they're both perfect cubes, you put a little parentheses and then a big parentheses. And the cube root of x cubed is x. The cube root of 8 is 2. And Caleb, Matthew, whatever this sign is right here, this minus sign, whatever that sign is, always goes right there. In this case, it's a negative sign, so we put a negative sign. Okay? Next, you take this term right here with a dot under it, and you multiply it by itself. So x times x would be x squared, and that goes right here. Then you take this term with a dot, and you multiply them together. Don't worry about the signs. x times 2 would be 2x. Then you take this term right here with a dot under it, you multiply it by itself. So 2 times 2 is 4. Good, yes. Caleb, Matthew just said, are both of these plus signs? And yes, they are. Whenever this is negative, it goes positive, positive, positive. Now, if this was a positive sign right here, if this was a positive, then it would go positive, negative, positive. Okay, so write that down if you need to, guys. But anyways, so I can now quickly get rid of this and put this in place of it. Okay. Now, factoring the denominator should be really simple. I mean, what two numbers multiply together give you 4, when add together give you 2. No, it can't be factored. I'm sorry, the bottom cannot be factored, but look what can cancel. You can cancel. Because there's no two numbers multiply together that give you 4, when add together give you a positive 2. But look what I have here. I have this trinomial here that cancels with this trinomial here. So I did all that work, which was really helpful. It's very helpful that I did this. I'm now left with just x minus 2. And that's really helpful, okay? So now I have the logarithm of x minus 2. And then bring down your other logarithm here, plus natural log of x plus 2. And now you have two logarithms that are being added, so you write the logarithm once, you multiply the arguments, and x minus 2 times x plus 2. If you do the FOIL method, take x times 2, negative 2 times x, negative 2 times 2, you will get this right here. And do put parentheses around it. If you don't, then we're going to think you're just taking the logarithm of x squared. Okay? There we go. Think it through. Yes, sir. And you know that because you're down to one logarithm. There's nothing else you can do. You have one logarithm left. Okay, 2 more and we're done with our first page today. All right, let's expand this, okay? Now, here's the first thing I want to show you guys. First of all, notice there's a 4 here, okay? And so really, see if this makes sense, guys. I can really put parentheses, WR squared, and take this whole thing to the what power? 1/4. Because a fourth root means a 1/4 power. Now next, there's a 1 with a W here, even though you can't see it. It's W to the 1 power. Take your 1/4 and multiply it through, and now you have natural log of W to the 1/4 R to the 1/2, because 2 times 1/4 is 1/2. And now, guys, you are so good to go. You have an argument that's multiplying. You have a W times an R. A W times an R. So whenever your argument is multiplying, that means you're going to use a plus sign. So you write a natural log here, you write a natural log here, and the one argument is W to the 1/4, and the other part of your argument is R to the 1/2. Well, no, because Caleb, Matthew just said, is that it? And no, it's not, because see this 1/4, if we're expanding it, we're making it as big as possible. So the 1/4 should go right here. And the 1/2, I know I'm being a little sloppy here, guys, but I'm doing that to save time. The 1/2 can go right here. And now you've expanded it. Now, how do I know I'm done? Well, look at this argument. It's only a W. There's nothing multiplying or dividing. Look at this argument, Matthew. It's an R. There's nothing multiplying or dividing, so we know that we're finished. Okay, number 62. Okay, same thing. The first thing I would do is I would write m squared on the test. Not any harder than this, no. Just all the fundamentals here. The first thing I would do is get rid of the cubed root. I would take the whole thing to the 1/3 power. Now, there's an exponent of 1 with the n, so when you take the 1/3 and multiply it through, you will get m to the 2/3 over n to the 1/3. 2 times 1/3 is 2/3, 1 times 1/3 is 1/3. Now, next, notice, Matthew, what is your argument doing? Dividing. So if it's dividing, you want to put a minus sign, and we're going to put a log here and a log here. and then we're going to put the numerator here, so the log of m to the 2/3 minus the log of n to the 1/3. There we go. Right. I'm going to take this 1/3. I'm going to put it right here to the left. Caleb, hopefully you're getting all of this. I'm going to take this 2/3 and put it right here. Now, the only thing is, check your arguments. The argument over here is just m. Is there anything multiplying or dividing? No, not at all. Over here, your argument is an n. There's nothing multiplying or dividing, so you're finished, okay? All right, one page down, and Caleb, it's kind of funny, but you're at the mercy of Matthew today, so whatever he wants to go over, we'll have to do. So he's going to glance at his test real quick, or whatever he wants to do, and see what else he would struggle with. Take your time, Matthew. Make it a good. Page 397 is it's numbers 10 through 16 in the test. Yeah. Do you think you would struggle with those? It's up to you. Let me pause the video real quick here, Caleb, or Matthew. Okay, Caleb, we're back. We're going to do numbers 54 through 72, all of these numbers here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's about 13 pages down. There it is. Okay. Let's see. What do the directions say for that, Matthew? Oh, I know what it says. Never mind. Okay, Caleb, you're going to have to turn your book to this. And Matthew, in your book on that page, in the directions, they should say, and Caleb, Matthew's using my book right now, so I don't have to kind of talk to him a lot. Matthew, they should give you a couple logarithms in the directions, like log of, what do they give you? Log of what? 2? And I don't need to know the equals part, just log of 2. And what else do they give us? Okay. Log of 7. So Caleb, if you'll look in the directions on this page, and we're going to do page 397 right now, Caleb, page 397, we're going to use these three logarithms to solve this logarithm. Now, the first thing I noticed, Matthew, is they want us to solve log base a of 14. Well, I have no idea what that is, but I know I can rewrite the 14 because I know my logarithmic properties as what? Very good, 7 times 2. And then, because my argument is multiplying, I can then write two logarithms, Caleb, hopefully you're getting this, that are being added. So log of 7 plus logarithm of 2. And then I don't have my book in front of me, but Caleb, you and Matthew are sharp young men. So in your book, whatever the directions say the log of 7 is, put that number right here, and whatever the point what? Okay, 0.845, and then what's the logarithm of 2, Matthew? 0.301. Add those two together, and we'll get a 6, a 4, 11, 1.146. Okay, so there we go. Caleb, what you're trying to do here is take the 14 and break it down into numbers using 2, 7, and 11. Okay, moving on to this one here. This one here looks a little difficult because logarithm of 1/7. I mean, what are we going to do here? Well, first of all, I want to remind you guys, please don't forget this, Matthew, Caleb. I don't care if your base is 5,692. If you're taking the logarithm of 1, it's always going to equal what? Always. So we know the logarithm of 1 is 0, and the denominator is 7. Well, you have an argument here that's dividing. So if your argument's dividing, you can really write log base. Yep, exactly. So we have here log base a of 1 minus log base a of 7. And Caleb, the reason we did that, our argument is dividing, so we put a minus sign here. And then the logarithm of 1 is always going to be 0, and the logarithm of 7 was 0.845. And so obviously the answer is negative 0.845, unless I'm making a mistake somewhere. All right. Okay, moving on to number 50, whatever's next here, I don't know. 60, number 60. Okay, 5/3. Now, did the directions change, Matthew? Are we in another section now? I think they did. Okay, so now, Caleb, we're on a different set of directions. What logs did they give us, Matthew? Log of log of 2, log of 3, and logarithm of 5. So if you'll look in the directions, Caleb, for number 60, page 397, you will see they've given us values for these three logs. Well, this is easy. I mean, log of 5/3, we know that the argument's dividing, so it would be log of A of log base A of 5 minus, or it's B, sorry, log base B of 5 minus log base B of 3. And what do we have here, Matthew?
Log base 5 is 1.609.
Okay.
Log 3 is 1.099.
Okay, I'm going to save time here, Caleb, Matthew. You can subtract that on your own and get the answer. Let's go on, okay? Moving on to number 62, log base B of 30. Now, Matthew, any ideas? I'm going to glance back and look here at what I have. Oh, I see what to do. How can we take this 30 and break it down using the numbers that we have, Matthew? Any ideas? Using a 2, a 3, and a 5. Multiplying? Good. Okay, Caleb, what he said is log base B of 2 times 3 times 5, which is 30. That's totally fine. So your argument's multiplying, so now I'm going to put log base B of 2 plus log base B of 3 plus log base B of 5. Now, Matthew, Caleb, you guys know me. I think you love this. There's probably plenty of things I do you guys don't like, but one thing you guys probably like is how I can skip things that you know how to do. All of you young men know how to put a number in for this log, a number in for this logarithm, a number in for this logarithm, and then add them all together. You guys all know how to do that, okay? So we're going to move on just a second. I'll wait for Matthew here, Caleb, then we'll go on. Okay, Caleb, we are back with a rocking great pre-calculus class. Number 66 is next. Now, I believe numbers 66, 68, and 72 you're simplifying, and so we're going to use, if I can get this thing to work here, our logarithmic properties. So when you look at this, you're saying to yourself, well, Mr. Earhart taught me whenever the base of the logarithm matches the base of the argument, the entire thing equals just the exponent. So there's your answer. Easy enough. Okay, moving on to number 68. When you look at this one here, it's kind of the same thing, but you got to do a little creativity first. No, I guess you don't. I wish I would have given you guys a different problem. That's a little redundant. Whenever the base of the logarithm matches the base of the argument, the entire thing just equals the exponent. So there we go. Same log property used in two different problems. You need something, Josh? I have no idea, and I would leave well enough alone, because you know when these guys leave, he's got homeschool to do the rest of the day. Okay, you take care of yourself. Oh, Caleb Banks that's why we're videotaping this. He said he's sick, but we think he's out the lake somewhere. I'm kidding. He's sick, Josh. All right, moving on to number 72. All right, here's what I taught you men on this property. What we learned is this. First of all, I'm going to squeeze an E in here, Matthew. Hope that's okay to do. There we go, because the natural log means base E. What I said is whenever you have a logarithm written as an exponent and the base of the exponent here matches the base of the logarithm, the entire expression equals the argument, and the argument is x cubed. Okay? There we go. Moving on. One whole page knocked out and two more to go. Well, let me pause the video so we can discuss this. Okay, Caleb, we are back again with a highlight of your day. Let's take a look here. Matthew, Caleb, wants to look at some graphing problems. So on your test, if you'll look at numbers 6 through 9 on your test, that's going to be two problems, page 387, numbers 2 and 84. Numbers 2 and 84. Okay? So if you want, Matthew, it's totally up to you. We can do the whole page. Okay, so Caleb, we have voted on it. Just kidding. Matthew has voted on it, and he's decided he wants to do this whole page here. So that's what we're going to do. Yeah, so what we're going to do exactly, we're going to do number 2, Caleb, and then number 84 because they both go together, and then we'll do 10 through 74. Okay. So here we go. Now number, sorry, Caleb. When you look at number, let me get a drink here. When you look at number 2, I want you to be very careful with this. When you look at that, you're saying, dude, that's an exponential equation, and I'm saying, dude, not. Okay, because all the exponential functions that you graphed were the y was by itself and the x was your exponent. So this is not as easy as you think it is. This is totally turned around from what I taught you. So my advice is to write it logarithmically. So if you write this logarithmically, you'll have this. Now I'm going to be honest with you. I didn't give you one of these on your test. If you'll look at your test, number 6 through 9, I gave you 2 logarithms, number 7 and 8. So you won't have to do what I'm doing. Yes, well, they'll be like this here. Once I write it logarithmically, you'll see it's just
Like not log basis, something just regular log.
no, they have bases.
I mean, like we know it's a 10, like unless something's
Right, that is true. Yeah, so if you look at number 7, 7's a base 10, and if you look at number 8 on your test, base 3. Okay, okay, good question. That's a very good question. Now, so on the test, Caleb, understand I'm not going to give you one that starts off like this. Just go ahead and get rid of it. I just wanted you to see that. The ones I give you on the test look like this. Okay? So, here's what I've taught you to do. Step 1, I've taught you to isolate the logarithm. Okay? Well, no, I guess I haven't taught you that. No, let's not do that. What I've said is every single logarithmic graph has a vertical asymptote. And you find the vertical asymptote by taking the argument and setting it equal to 0. So my argument is x equals 0. These were on your quiz, Matthew. You did well in your, yeah. And so you know your vertical asymptote is at 0. So yes, sir. Caleb, I'm back. Matthew, here we go. So do you guys understand? Take your argument, set it equal to 0. That's going to be your vertical asymptote. So I'm going to take a red pen because I'm just so creative and put my vertical asymptote right here. Now, guys, buddy, she read the card. Trust me. She did the whole thing. You can ask her when she gets home, okay? She did the whole thing. Now, guys, look. Either you're going to plot values to the right, Matthew, or you're going to plot values to the left. Yeah, Caleb, Matthew just said to the right. There's no way you're going to put -1 or -2 or -3 in because you can't take the logarithm of a -1 or a -2. So the values you're going to put in, are going to be 1, 2, 3, and 4. Now, I don't have my calculator handy. Yes, sorry. Yes, very good point. We want to get real close to the asymptote, Caleb. So Matthew's right. We want to go barely past the asymptote. So I'm going to put 0.1. So if you put a 0.1 in for x, it's really going to be log 0.1 over log of 4. And what do we get, Matthew, if we do that? Negative 1.7. Okay, so there we go. So 0.1 is negative 1.7, so about right here. And then if you put a 1 in, we know the logarithm of 1 is always going to be 0. And then I'm sure 2 is going to be up here somewhere. 3 is going to be up here. It's going to look like this, Caleb. I'm just trying to save time again. You guys know how to type these in. It's going to be your typical standard curve, just like this. There we go. Now that's called graphing a logarithmic function. All right. Most definitely, yes. We're going to go ahead and fill in this table of values here, Caleb. Okay, Caleb, I'm back. Here's the table of values. You can fill yours in if you want to. I guess I went too high on my graph there. I'm going to change colors. So it should have gone, let's see, 1 is 0, 2 is a half, 3 is 0.8, 4 is 1. So it's kind of looking like this, actually. a little slower increase. But either way, it's still pretty much the standard curve, okay? All right, now the next one we're going to do, number 84, that's about 10 pages up here, so see if we can find it. Okay, here's number 84 right here. Now, Matthew, go ahead and type this into your calculator the way that I taught you real quick if you would, so we have our table of values ready. And Caleb, just ignore us for a second. So log of x minus 2, and then close the parentheses, and then divide it by. And then log of 3. And then we go right to our table of values here in a second. Let me look at me. Okay, sounds good. Okay. Yep, that sounds exactly right. Okay, Caleb, thanks for waiting. We're back. Okay, let's graph this logarithmic function here. First of all, you see it's a logarithmic function, so you know right away you have a vertical asymptote. You find the vertical asymptote by taking the argument, which is x minus 2, and setting it equal to 0. And then, don't block Matthew's path of vision there, please. Thank you. And then if we bring the 2 over and make it a positive 2, there's our vertical asymptote. So we know our vertical asymptote is at 2. Now what we got to decide, Caleb and Matthew, is whether we're going to plot points to the right or to the left. Well, there's no way you're going to put in a 1. If you put a 1 right here, 1 minus 2 is a negative 1. You can never take the logarithm of 0 or a negative number. So I know I'm going to put in numbers like 1, this is 2, so I'm going to put in numbers like 2.1, 3, 4, 5, and 6, okay? And we're going to call those out really quick when Matthew's ready, so we'll let him get that ready for us. Now 2.1 we'll have to kind of do manually there, of course. Let's do the other ones for, okay, yeah, go ahead and do 2.1, it's fine. What do we get for 2.1 there? Negative. Okay, gotcha. And you can round them all, that's fine. This would be 1, right? 3 would be 1. Or 0. Yeah, that's right. 0.6. 1.3. Okay, there we go, Caleb. So over 2.1, down 2.1. So over 2.1, down 2.1, about right. 2.1, 2.1 about right here, and then 3 would be 0, and then 4 would be 0.6, and then 5 would be about a 1, and then 6 would be 1.3. So, you know, not perfect, but you're getting the idea, I hope. So there's the sketch. Now I will say this, Matthew and Caleb, please watch this, guys. I didn't make a mistake, I knew this. If you'll look at numbers 6 and 9 on your test, please, look at numbers 6 and 9 on your test. I didn't give you any problems on your review sheet for exponential graphs because they were on your last test. I just went ahead and included them because I wanted them to be mixed in with logarithmic functions. So let me very quickly, I'm not going to bore you, but I'm going to throw a quick problem up here. Don't forget when you're graphing logarithmic, just kind of walk through it. You don't have to do it. No. Caleb, you don't have to take notes unless you want to. What I've taught you guys is this. An exponential function will have a horizontal asymptote. Remember that? And it's always at the what? Whatever your constant term is. In this case, your constant term is 4. So your horizontal asymptote would be at 4. So that's the first thing you need to remember.
What are these called?
Exponential graphs. Okay, Caleb? And then, how do you know what to do for your table of values? You always take your exponent and set it equal to 0 and solve. And whatever you get, that goes right smack dab in the middle of your table of values. So you would put a 2 right here. And then a 3, then a 4, then a 1, then a 0. Let me do so quickly. Put a 4 in, 2, 4, 12, that'd be a 16. Put a 3 in, 2, 6, that'd be a 10. Put a 2 in, that'd be 1, 3, 7. Put a 1 in, 1 half. I don't think so. You'll see. It's getting closer and closer now. See, it went from 16 to 10 to 7 to 5.5. True. I'll show you in a second how it looks.
Oh, it's on the top.
Right. And then this would be 4 3/4 right here. 4 3/4. So at 1, 2, 3, 4, 5, 6, 7. At 4, you're way up here at 16 somewhere. At 3, you're at like 10. At 2, you're at 7. At 1, you're at, I don't know, 5.5. At 0, you're at 4 3/4. And so the graph will be a typical curve like this. Okay, I did it quickly, but you get the idea. This was on your last test, and you guys did fine with your last test, but I did put these on this test also. None of these are on your review sheet, okay? Okay, moving on. Here we go. Let's wipe this whole page out. So let's get after it. Here we go.
Number 10 is the
Yep, here we go. Okay, Caleb, we're going to wipe out, what time is it, Matthew, so we can keep track of that. If you'd keep your phone out, that'd be a big help. My phone's way over there. What time is it? Oh, wow, we're doing really well. Okay, let's knock out numbers 10 through 74. Caleb, on page 387, okay? All right, number 10, they're wanting us to solve this. Now, hopefully you know by now your calculator, and I don't want you to use a calculator on these. So you admit that you don't know what it equals, and you set it equal to x.
You just said the non to be squared, and then the exponent would be
2.
x.
Yes, as long as you understand that. As long as you know that, yes. So what we do next, Caleb, is we write it exponentially. So 3 to the x equals 9. And then what you're trying to do now is you're trying to write both sides with the same base. And so my 9 can be rewritten as 3 squared. And now notice both sides have a base of 3. Well, when both sides have the same base, you can basically just cross off the base and set the exponents equal. So obviously x equals 2. All right, let's move on to the next one. Caleb, what do you need? Okay, do you know who has it? Did you ask them? Go ask them and tell them I said you need to use it, okay? If there's a problem, come tell me. Okay, here we go again, guys. We're solving a logarithm without a calculator. There's no base, so we know it's a base 10. Set it equal to x. Write it exponentially. So 10 to the x equals 100. And come on, guys, this is so easy. We want to write both sides with the same power. Obviously, 100 can be rewritten as 10 squared. And so x equals 2. Matthew, am I going too fast? Okay, moving on to the next one. Caleb, hope you're hanging in there with us. All right, we're solving this without a calculator. And so the first thing we do is we set it equal to x. Yes, sir, go right ahead.
Would you eventually, like, not, but you can't, like, raise the 2, but you can lower the 8?
Right, exactly. What Matthew said, Caleb, is he said you really can't change the 2, but you can change the 8, and he's exactly right. Okay, so again, our goal is to write both sides with the same base. And 8 is the same thing as 2 to the 3rd power. Let me get a drink here real quick. You got it, yes, sir. And so, Caleb, don't forget there's an x right here. And now we know this from Algebra 2, guys. Whenever you take a power raised to a power, you multiply your two exponents. So really, we have 2 equals 2 to the 3x. And there's a 1 right here, even though you can't see it. So now whenever your bases match and there's nothing else, you have one base on one side, one base on the other, cross your bases off, set your exponents equal, divide both sides by 3, and x equals 1/3. So you just solved a pretty difficult logarithm without a calculator. Log base 8 of 2 equals 1/3. It equals 1/3. Okay, let's take a look at this one here. Now I think there's some more difficult ones as we get going, I believe. Now this one here, it's just there's really no work to show. I mean, at first there was when I first introduced you guys to logarithms, Caleb, Matthew, we would work this out. But since then, you've learned the property that states whenever you take the logarithm of 1, the answer is always 0. So the answer is 0. Okay? I mean, you can set it equal to x if you want to, and you can write 5 to the x power equals 1. That's fine. But the only thing that would satisfy x is 0. 5 to the 0 power is 1. Okay, moving on to number 32. Okay, here we admit that we don't know what the answer is, so we set it equal to x. And I'll be honest again, Matthew, Caleb, look, hold on. See this base right here, Matthew? We've learned a shortcut here. I mean, we really have. I mean, right, exactly. Caleb, we've learned that whenever the base of a logarithm matches the base of a log, the answer is just the exponent. But again, just in case you're confused, go ahead and set it equal to x, and now write it exponentially. This is an e here, so e to the x equals e to the negative 5. And so obviously x equals negative 5. Okay? All right, moving on to number 36. Okay, now I think on this one, Matthew, can you turn over please to page 387 if you're not there already? Okay. Number 36, I think they're saying to us to just write it logarithmically. Yeah, that's all they want us to do. Okay. They want us to take this exponential expression right here and just write it logarithmically. So that's pretty easy to do. Your base of the exponent stays your base of the logarithm. All right. And your whatever's all by itself over here is always your argument. And your exponent here goes right here. We've learned how to do that, okay? So that's it. So we wrote it from exponential to logarithmic form. And the next problem, I'm pretty sure we're going to write a logarithmic expression in exponential form. Okay, well, let's write. Forget that. I'll show you why. Forget this problem was here, okay? Going the other way, right? Okay. Well, first of all, let me show you why, first of all. Okay. Well, let's take this. You know that if you have a log, I think you do better, though, going from a logarithm. We've done a lot of those. If it's written like this, you always take the base. Here's how I've always taught the kids. Whatever the base of the logarithm is also the base of your exponent. So if you have a base 5, you're going to have a base 5 here. And then whatever is over here is always your exponent. Always. And then your argument always goes over here all by itself. Okay? But now going backwards, what is the base of your exponent? 5. So that's good. So whatever your base is here, Caleb, whatever the base of your exponent is, that'll be the base of your logarithm. And then whatever's over here all by itself, that's always going to be your argument. And then the exponent right here, Matthew, the negative 3, the exponent always goes by itself over here. Okay, so there we go. That's kind of going both ways. Caleb, hopefully didn't confuse you there talking to Matthew a little bit, but let's take a look at one more. The next one, you're going to go from logarithm to exponential. Okay, so here's your logarithmic expression, and we're going to write that exponentially. So what is your base of your log? 4. So that stays your base. Nope. Remember, the whatever's all by itself. Good. So Caleb, talking to you now for a second, whatever the base of your logarithm is, that always stays the base of your exponent, and then whatever's all by itself in your logarithmic expression is your exponent, and then your argument is always by itself. So there we go. So we're learning how to write them logarithmically and exponentially. Okay, moving on to number 56. There we go. Now I think we're using a calculator on this one. And so it is a base 10 already. What do the directions say for 56, Matthew? I'm pretty sure it says to use a calculator. Yep. Okay. And so Caleb, notice it's already a base 10, Caleb, so we're good. Your calculator does base 10 and base E. So you just type in log of 8, enter. Okay. Yep, there you go. Now the next problem is a base E problem. It's a natural log, okay? The last one, don't forget, this is called a common log right here. Base 10 is a common log. This is called a natural log. And so your calculator does base E's. So you would hit natural log of 50, hit enter, and you will get 3.9120. Okay, very good. Moving on. Now we're going to get into the ones that your calculator doesn't do, quote unquote, specifically. Okay, so on the test or a quiz, if I ask you guys to type this into your calculator, the first thing you should notice is that your calculator only does base 10 and base E. It does not do base 5.3. So, well, it's a change of base formula. No, not at all. So remember, I would take the logarithm of my argument.
I guess it would matter if you did 5.3 first.
It would, yes. What Matthew asked, Caleb, is would it matter if you did 5.3 first up here? And the answer is yes. You'll get it wrong, definitely. Um, the argument goes up top, the logarithm of the argument, divided by the logarithm of the base. Now, notice what I did here, guys, is I rewrote a base 5.3 with a base of what? 10, a common log. By the way, you know what else you can do? You could use a natural log. You could take the natural log of 1700 over the natural log of 5.3. And if you don't believe me, men, go ahead and type both of these in. Type in log of 1700, be sure and hit enter, divided by log of 5.3, enter, and you'll get this answer right here. And then if you type this into your calculator, you'll get the exact same answer. Okay? Change the base for me. Matthew, what do you think? Good? Okay, Matthew's good. Caleb, hopefully you're good. Moving on to that page. Okay, done with that whole page. So we have one page left. What time is it now, Matthew? Are we cruising right along here? 38. Okay, well, if we finish early, we finish early. I definitely did not plan that, but if we do, we do. So count your blessings and be glad. It's logarithmic equations and exponential equations. It'll be so-so. We're going to jump now. You need something, Josh? Okay, we're going to jump to this page here. We've done this page here, Caleb. We've done this page here, and we've done this page here. So now we're on page 408. Okay, page 408. And we're just going to go right in order and knock these out. So here we go. Well, I was going the wrong way this whole time. Oh, my land sakes of Goshen. All right, let's try this again. Okay. Okay. Should be on the stand beside the dishwasher, to the right of the dishwasher. Are they over there in that little homeschool stand? Okay. What do you need the keys for? Oh, I saw it around here somewhere. It's downstairs. It's down by the washing machine, but no ignition, okay? Thank you. Okay, Caleb, sorry about the interruption. Matthew, sorry, here we go. Let's rock and roll. Let's see what we got here. Okay, 2 to the x equals 3 squared. Now listen to me, guys. Anytime you're solving an exponential equation, the best case scenario is when you can write both sides of the same base. Now, you can't always do that, but when you can, do it. And you can. 2 to the 5th power is 32. So now you see that x equals 5. They don't get much easier than that. I think I gave you one of those on your test. All right. Now, next problem. Oh, this is pretty easy too. I mean, look, you can definitely write both sides with the same base. 3 to the 7x equals 3 to the what power? 3 times 3 is 9 times 3 is 27. And now I have the same base on both sides, so I simply take my exponents, set them equal, divide both sides by 3, and I'm going to get 7/3 for my answer. Or you can put 2 1/3, or you can put 2.3 repeating. Either way is fine. Why is their answer saying 3/7? Did I mess up? Yeah, I really messed up. Caleb's probably laughing at his house right now. Or he's on the beach laying out. Just kidding, Caleb. I know you're sick. I'm just teasing you. Okay, cross off these 7s here, and x equals 3/7. Here we go. All right? Okay, moving on. Pretty good one. No, you can't. So we need these, okay? So this is good. Okay, now Caleb, this next one's going to be tough. You cannot write both sides of the same base. So when that happens, here's what you do. First of all, you must isolate the base of your unknown. Please listen to me, guys. I don't want to annoy you, but I've got to teach you. If the problem would have looked like this, you would bring the 3 over and make it a positive 3. You must get this all by itself first. You must, okay? So we cannot write both sides with a base of 2. So we make sure this base and its unknown are all by themselves, and they are. So what we do now is we look at the base of our unknown. The base of our unknown is 2. So because I have a 2 here, good. Good. We use the log base 2 of one side, Caleb, but if we take log base 2 of one side, we must take log base 2 of the other side. Okay? Now here's why you're out of lead. I don't know if I do. I will look. Let me pause the video. Did it come out? Okay. So, guys, here's why you did this. Caleb, look. You did this over here. The reason you wanted to write your base 2 to match your exponent 2 is, look, we learned a logarithmic property that states whenever your base matches your base, the entire logarithm equals the exponent. So this whole side equals x. So now you know what x equals. And yes, my voice just cracked. Now we can take x equals the logarithm of base 2 of 40. Well, no, what you would do is you would type this in your calculator. And you're probably saying, Mr. Earhart, you've lost it. Our calculator doesn't do base 2. Well, if your calculator doesn't do base 2, then use your change of base formula. Logarithm, logarithm of 40 divided by logarithm of 2. And if you'll type, now be sure and hit enter, Caleb, after you hit logarithm of 40. So log of 40, enter, divided by log of 2, enter, and you should get this answer right up here. 5.322. Matthew's checking it right now. You need to know how to do those, guys. It's a very standard exponential function, okay? Or exponential equation. Okay, here's another one. Now, this is a little more difficult, guys, so just understand it. This one's not going to be easy, okay? I'm going to tell you why. Let me walk you through the steps, and you listen to me, okay? Okay, listen. First of all, can you write both sides with the same base? No way. I mean, no way. Next, look at the last problem. The base of your unknown was 2. There was no x over here. There was only one x. But now look at this problem. You've got an x here and an x here. So what's the base of your unknown? 28 and 10. We got a problem. We have two different bases of two different unknowns. So we can't take the log of 28 of both sides. It's not going to help. We can't take the log of 10 of both sides. It's not going to help. So in this situation here, men, when you can't take when you have two different bases of your unknowns, you use common log. So watch what I do. I'm going to take I'm going to take the common log of 28 to the x. But if I take the common log of one side, I must take the common log of the other side. Okay? So whenever you have two different bases of unknowns, you take the common log of both sides. Now look what I can do next, guys. See this x right here? Where can I write it? Right there. See this negative 3x? Where can I write it? Well, you know. Right here. No, it is not. It's multiplying times the log. That's one of your logarithmic properties. Now, don't get confused, Matthew K. This is one whole term right here. They're all being multiplied. And this is one whole term. Every single term that has an x must go on one side. So both of these terms have an x. You want to get all of your x terms on one side. So x log of 28 plus, because you're going to bring this negative 3x over and make it positive, so plus 3x logarithm of 10 equals 0. Now guys, why would I do that? So I can factor out my x's. Factor out your x. And if you factor out an x, look what you're left over with. Logarithm of 28 plus 3 logarithm of 10. Do you see that? Factor out your x. Pull it out. There's an x in this term and an x in this term. And now, I know this is a pain, but these are the hard ones, guys. I don't think I gave you one of these on your test. I hope I did, but I think I did not do that. I should have. Now, you want to know what x is? Would you not divide both sides by this right here? I would. I would. You sure about that? Anything? Yep, you're right, but it's not always going to be that easy, so be careful. Sorry, Caleb, Matthew and I are having a little conversation here about World Cup soccer. So we're dividing this side over here by this whole expression, so we got to divide this side over here by the same expression. these cancel, and you're left with x equals 0 over logarithm of 28 plus 3 logarithm of 10. Now, listen to me, guys. Obviously, if you take 0 divided by any number, you'll get 0. Okay? Except one exception. One exception. What if this whole expression down here equals 0? No, it'd be undefined. You can never divide by 0, so 0 over 0 would be undefined. Well, the only way,
Well, I thought any number over any number is 1.
except for that exception. Yep, not there. Just so you know, that's a really good question. But no, if your denominator, actually, in calculus, you'll see if you put a 0 here, it's infinity. 0 over 0 is infinity or undefined. Now, Caleb, if you take log of 28, it's already base 10, so just type in your calculator. If you took log of 28, enter, plus 3 log of 10, enter, you'll see you don't get 0, you get some number, so we're okay. So 0 divided by any number except 0 is going to be 0, so the answer is 0. So there's your answer, okay? But look this over again. If you got to back it up, Caleb, back it up. I'm going to talk to Matthew now and see if he has any questions, okay? But that's how you would do that. It's not easy, and you got to go back and study that, okay?
Would we have one that's 0 over 0 on the 10?
No, I would not do that to you, no, sir. No. I will say this again, guys, in reviewing. Notice the base of your unknown and the base of your unknown were two different bases. When that happens, you've got to use common logs, okay? Okay, Mr. Sheets, Mr. Banks, let's roll on. Here we go. There it is. There's the wonderful, exciting, awesome, beautiful problem that we're going to do. And let's get after it. You know what I noticed right away, much to your dismay? I noticed we have a base of an unknown that's 5 and a base of an unknown that's 4. We would use, it's going to be a doozy. I'm just going to be a crazy problem, okay? So be ready for it. Probably. Now you're kind of, we've only got 6 left. And what time is it now, Matthew? So if we don't, we're going to get them all done. I'm not worried about it, but we're doing great. But so just to use a coach's term like Dwight, just suck it up, guys. Let's get it done, okay? So here we go. Common log of both sides. So I'm going to take the common log of 5 to the x plus 2 power equals the common log of 4 to the 1 minus x power. Now the next thing I'm going to do is I'm going to take my x plus 2 and put it out front. But when I put my x plus 2 out front, look what I do. You better put parentheses around it, guys. I'm telling you, you better put parentheses around it because you're taking the whole expression times the logarithm. Same thing with 1 minus x. We good so far? Okay. Now, next, you really have x times the logarithm and 2 times the logarithm. So now what I have is x logarithm of 5 plus 2 logarithm of 5.
So now they're going to be multiplied now.
Well, if you don't want to do that, you'll come back up here. You'll get what you started with up here. Remember, don't lose sight of the trees for the forest here. We're trying to solve. We're trying to find out what x equals. Now, Caleb, if you're watching here, you take 1 times your log, negative x times your log. You would have 1 times log of 4. And I'm not going to put that 1 there, guys. That's really a waste of space. So log of 4. Then be careful. It's a negative x. So negative x times logarithm of 4. Okay? Now, I need more room. Remember in the last problem, I did warn you guys about this, and hopefully you were listening. And you guys, I do know what I'm talking about, and I told you any term that has a what in it, you got to get on the same side. Okay, so this term has an x in it. This term has an x in it. You got to get all your x terms on one side and all the other terms on the other side. So now what I would have, I'm going to try to slide stuff around, be a little tricky here. Hopefully it'll work. I'm going to take this negative logarithm over here, and when I do, it's going to be positive. I'm going to take this logarithm here and bring it over, and when I do, it's going to be negative. And this one here, of course, will be positive. Matthew, is that what you got? See if that's what you got. Check it carefully, please. Okay, now the reason we did that is we're going to factor out our x. So I'm going to factor out my x, and I'm left with logarithm of 5.
We always factor out.
Yes, you will. That's why you want to get all your x terms on one side, so you can factor out your x. And now I'm not going to write this, but you understand you would divide both sides by this here. So here's what you would have. Ready? You would have x equals this expression here divided by this expression right here. And now really my opinion is I think you should practice typing this into your calculator. Now if you don't want to, that's your business, guys. But I would simplify the numerator. So Matthew, let's take log of 4, enter, and then minus 2 log 5, enter, and see what you get. Negative 0.7959. Sounds good to me. Hopefully he's right. I'm trusting him there. And then log of 5, enter, plus log of 4, enter. Oh, yeah, plus, yeah. Log of 5 plus log of 4. 1.3010. Now, if you take these two numbers, Caleb, Matthew, and divide them out, you should get this. You should get whatever our answer is here. Do I have the answer? You should get negative 0.612. I hope we do. If not, we've made a mistake. So negative point, what did I say it was again? 612. Let's see what you get. What'd you get, Matthew? Okay, let's make sure, because I think I'm going to make a mistake somewhere. Negative 0.612. Close enough, yeah, okay. All right, there we go. Caleb, hopefully you're hanging in there, buddy, okay? All right, moving on to the next one. So these are called exponential equations. What is the number one thing you want to do if you can? Write both sides of the same base. But if you can't, then you've got to use logarithms to solve, okay? All right. Well, it depends. That's a good question. Right, very good. Yes, you would. Yep. Yep. And don't worry, Matthew, I'm not going to bore you, but look at that. The only thing is when you only have one base, then you took the log base of what? Because the base of your unknown was 2. But yes, you're right. Whenever you have two different unknowns, you always use common logs. Yes, definitely. Yep. Okay, now we're moving to logarithmic equations. So the rest of the review sheet, numbers, I believe the rest of the review sheet, I could be wrong, but I think the rest of the review sheet is going to be, I think they are. Exponentials take a lot more creativity. Logarithms are a little more standard, a little more structured. We did, yep. This is the last thing we did of the whole year, last notes day that we had. So it's kind of sad, isn't it? If you guys want, Caleb, if you guys want to meet over the summer, we'll start a math club. Just kidding. Nerd. Just kidding. All right. Here we go. All right. Now listen, when you're solving logarithmic equations, remember, your goal is to get one log on one side and one log on the other, if you can, okay? Now in this case we only have one log, so we're okay. We only have one log on this side, so get it all by itself. Well, it is. Do you see anything to the left of the logarithm? No. Here's my argument. It's all by itself. So if your logarithm is all by itself, then write it exponentially. If your logarithm is all by itself and you only have one logarithm on one side, write it exponentially. And now look what x equals. Type into your calculator. 2 to the negative 1/3. You should get 1/8. Well, you're writing it from a logarithmic expression. I'd beg to differ with you. Okay, but look over here. If you had a true, but do you see what I have written here? Is that what you got? So tell me out loud, what does x equal? 2 to the... No, it would not. Remember, 2 to the negative 3rd really means 1 over 2 to the 3rd. Remember, you move the 2 to the bottom. So it'd be 1/8. Or you can just type into your calculator, which I recommend, I have no problem. If you type in 2 to the negative 3rd, it should give you 0.125. 0.125, either one of those answers. So Caleb, let me talk to you for a second. What we do is if you have one log on one side and that log is totally isolated, which it is, then go ahead and write your expression exponentially, and then just go ahead and solve it. Okay. And you can see what x equals here, Matthew. X equals 2 to the negative third. So if that's what it equals, Caleb, just type it in your calculator and you'll get either one of these two answers. Okay. All right, number 32. Kind of the same thing, but you're going to see it's not. Okay. Kind of the same, but not really. Now, is it a logarithmic equation? Yes. Yes, it is. And notice, Caleb, Matthew, we have one log on this side and no logs over here. So we want to write it exponentially, but hold it. Make sure your logarithm is isolated. Is there anything to the left over here? No. Do we have just the log and its argument? Yes. So we're ready to write it exponentially. So I would get 125 to the x power equals, ooh, this is ugly. This is ugly. All right. We've got to write both sides with the same base. Good, nice job. He said 5. He said 13. Matthew's way off, Caleb. I don't know how I can teach this kid. It's amazing what I'm doing with what I have to work with. Just kidding. All right, Matthew said 5, Caleb, and he's right. 125 is 5 to the third power. Well, let's see, maybe not, because look, guys, now you have 1 over, be careful, 1 over 5 squared. Right? Well, let's see. First of all, we know we have this, right? 5 to the what? Okay, sorry. I thought you gave me the answer. Should I give me the answer? Oh, sorry. Okay. Yes. Since Matthew's going to be on YouTube, I want to defend him. He said 5 to the 3x, and he's right, Caleb. That's exactly right. 3 times x is 3x. Now, over here, you have 5 to the positive 2. If you bring your 5 to the numerator, the 5 doesn't change, but the 2 does. Look at that. That's algebra 2 properties, Caleb. Hopefully you got those. Right. Now what Matthew just called out, Caleb, he said, oh, 3x equals negative 2. He's right. You have a base and an exponent here, a base and an exponent on this side. Your bases are the same, so basically cross them off. 3x equals negative 2. Divide both sides by 3, and x equals negative 2/3. I forgot something. Oh, my goodness. Let's go back, Matthew. It's very important. Guys, whenever you're solving logarithmic equations, sometimes you get no solution. Always take your answer and put it into the argument and make sure you don't have a negative argument. Well, if you put 1/8 in for x, you're fine over here, no problem there. And this one here, we're okay because is there an unknown in your argument? No, there's no unknown here, so we're okay. But always check your answers in logarithmic equations, always. No, sometimes there'll be no solution. That's definitely a possibility. Okay. All right, moving on to number 34. All right, now, be really careful. Notice, men, that again, it's a logarithmic equation. Obviously, it's a base e. Notice you have one log on one side. And by the way, hang in there. I know Matthew's getting a little fidgety. We got 4 problems left, okay? 4 problems, and we're done for the whole year when it comes to review sheets. So be thankful for that, okay? Now, look, you have one log on one side and no log on the other side. So we're going to write it exponentially. But hold it. Is there anything to the left? No. Do we have just the log and its argument? Yes. So let's write it exponentially. E to the negative 2 equals x. So there, what does x equal? E to the negative 2. Type it in. Type that into your calculator and you will get the answer, whatever that would be. I'm not sure. Matthew's. Well, x equals what? E to the negative 2. X equals e to the negative 2. So you want to hit your second natural log, so e pops up, then type in negative 2. There we go. We did it. We solved for x. Okay? All right, moving on to number 36. I'm really getting emotional. It's getting toward the end of our last review. See, the emotion I'm feeling is joy, pure bliss. All right, now once again, Caleb, Matthew, we have one logarithm on one side, okay? Now, Caleb, Matthew, listen, if there would have been a 2 right here, if there was a 2 there, you would move it. You would have to put it right here. Okay, listen, before you write it exponentially, there could be nothing to the left of the log, and the log must be all by itself. Okay, let's write this exponentially. 8 minus 7x equals what? 5 to the third. Now, instead of having 5 to the third right here, I'm going to go ahead and put 125. And now you know what to do. Bring the 8 over and make it a negative 8. When you do, you're left with 117. Now divide both sides by a negative 7. And you'll get negative 117 over 7. Now hold it, it might be no solution. You've got to take that, put it into your argument, and make sure you get out a positive argument. And you do. You do. Okay, but just make sure. Always check. Okay, moving on to 38 and 42. Matthew, you okay? All right. All right, now we're finally getting to some real problems. Good. Okay, now notice we have no logarithms on this side over here, but we have 2 over here. So our goal is to get, remember I told you our goal was the very first log equation we did, guys. I said your goal is to get 1 log on one side and 1 log on the other side. Now if there's no logarithms over here, then don't worry about it. But our goal is to get 1 log over here. Well, let me ask you a question. Is there anything to the left of this log? No. Is there anything to the left of this log? No. Do they both have the same base? Yes. What are the 2 logs doing to each other? Adding. So we know how to condense that. We put log base 2 and we multiply the arguments together, and you'll get this. Yes, Kayla, we need. Until they're done. Matthew, what time is it, please? I would say we have 3 more problems. We're probably done about 15 more minutes. Okay? That's up to you. I've told you whatever. You pay the price in the afternoon if your homework's not done, okay? Matthew, do you see where I got x squared minus 1? Caleb, I took x times x times negative 1, 1 times x, 1 times negative 1, you get x squared minus 1, okay? All right. Now, do I have 1 logarithm on one side? Yes. Is there anything to the left right here? No. So I can write it exponentially. So if I write it exponentially, I will have x squared minus 1 equals what? 2 to the third. And 2 to the third is 8. And now bring the 1 over and make it a positive 1. X squared equals 9. Good. X equals plus minus 3. Good. I was waiting. Caleb, you're not here, but I was waiting to see if Matthew would say something. And I hit him with something. He finally said, I'm not really. He totally saw it on his own. Negative 3 doesn't work, Caleb. If you put it only has to fail in one argument, and it fails. If you put a negative 3 here, negative 3 plus 1 gives you a negative 2. You can never have a negative argument. Now check your positive 3 too, but you can see if you put a positive 3 here and a positive 3 here, you would get a positive argument, so your answer is positive 3. All right? Okay. We have 1 left. How exciting, guys. I'm so proud of what you guys have accomplished this year. I love my kids, but I wish I had a little more free time. We'd have a party or something, have a little bit of fun, but I just have so much going on with 5 kids, but I'm very glad we've had a good year. And Caleb, before I end this video, I will talk to you and Matthew about what we're doing for the rest of the week, okay? Okay, now notice here you have logarithms on both sides, okay? And what did I tell you guys at the very beginning of this section? You want to get 1 log on one side. 1 log on one side. I'm sorry, 1 log on both sides. Well, look, isn't the right side already done for you? We have 1 log. That's good. But over here, do I have anything to the left? No. Anything to the left? No. They're both a common log. So I can rewrite this as 1 log. They're being subtracted as long as I put x plus 5 over x minus 3. Caleb, hopefully you're seeing that, okay? And now here's why you always want to. Whenever you have logs on both sides, the reason you want to get 1 log on one side and 1 log on the other side is now you can cross your logarithms off. You have log base 10 here, and you have log base 10 here. Is there anything to the left of this? No. Anything to the left of this? No. So just cross off your logarithms. And now just set the arguments equal. So what you really have is x plus 5 over x minus 3 equals 2. Now, what is in the bottom of your fraction that you would like to get rid of so you have no fractions? X. Good. Matthew said multiply everything by x minus 3, and he's right. So Caleb multiplied the entire equation by x minus 3. This would cancel with this, leaving you with x plus 5. And then, of course, 2's over 1 over here, really. You would take x minus 3 times 2, which would give you 2x minus 6. Now I'm going to finish this right up here. Bring your 2x over. It's a negative 2x, gives you a negative x. Bring your 5 over, makes it a negative 5. That gives you a negative 11. Divide both sides by negative 1, and x equals, you get 11, Matthew? Now be careful. Be careful.
Because you brought 2x over and it's negative 1x.
Okay? And then bring the 5 over, make it a negative 5, be a negative 11, and then divide both sides by negative 1, you get 11. Now, you got to check your answer. Everywhere you put 11 in, you get out a positive argument. Okay, so we're good. We don't worry about putting 11 over here because there's no x with your argument, so we're not worried about it. But 11 does work, so there's your answer. Okay? It is. Yep, it is. Now let's talk about next week. And Matthew, I'm going to talk about it now. Please ask questions, Matthew. I want you to do that because you might ask the same questions that Caleb has. I'm going to get a drink here and we'll wrap this up. What time is it? What is that? Gotcha. Okay. Matthew and Caleb, here we go. I'm going to write this down for you. And I want to warn you, you're not going to like this. Okay, one thing about Mr. Earhart, I shoot from the hip. Okay, I'm not mean. I feel like I'm really balanced. I just shoot from the hip. For example, I could make your test be due on Monday. Why not? I mean, hey, today's test day, but I give you 2 days. So I try to be balanced, okay? I'm going to review graphing, all the graphing that we've done, not for the whole year, just all the graphing we've done this semester will be on tomorrow's video. It'll be about an hour long, okay? In fact, I've already made it. Have I made it? No, I haven't, but I guess 15, 17 problems, something like that. It'll be about an hour, but there's no homework. You just watch it, do it, and here's how you get 5 points on your exam. That's it. That's how you get 5 points. You do the review sheet you do Tuesday with me. You take notes on, okay? If you don't want the 5 bonus points, then fine. It's up to you, okay? And again, we're men of integrity, so I trust you to be honest. By the way, Caleb, I need to hear from you on your homework and let me know where you're at today, okay? Wednesday, I'm going to go over equations that we've learned this semester, and there's so many of them, it's going to take 2 days, okay? Every day has about 15 problems, okay? Now that means your test is going to have 45 problems, but not really because just trust me, it's not going to be that bad, but your final will be on Friday. Now, I want to tell you guys something. It is worth 20% of your semester grade. It's going to be a tough test. Excuse me, sorry. And it'll be about 30 problems, maybe a little more. 30. It's going to be a typical exam, okay, guys? That's regular high school, and I know this is probably one of the hardest classes you take, maybe the hardest one you take, but it's over, okay? It's over. So don't quit until you're done. But after this, you're done. Now I'm really open. It was kind of funny, Caleb. Matthew and I were talking about when the test should be due, and Matthew's like, "Well, how about Tuesday?" And I was thinking about Wednesday, So I was like, "Okay, Tuesday's good," but really, I was thinking Wednesday, and Matthew said Tuesday, but before you TP Matthew's house, we're going to go with Wednesday, okay? So I'm giving you, if I give you too much time, guys, you're going to wait and you're going to forget everything. If I don't give you enough time, it's going to be frustrating. Now, really, I'd like it done by Friday. That way you're done for the whole year. But think when we're ending. What is the date this Friday? 11, 12, 13, 16th. We're ending on May 16th? That's crazy. You guys have earned that. You've earned it. You've done great. We've done 17 weeks, plus we've done 7 Saturdays, and each one of those is about a half a day. So we've done about 4 days, which is another week. So we've done our 18 weeks, but you've done great. So if you finish next Wednesday, you're really looking at May 20th. Is that right?
What time does everyone else go?
Maybe May 21st. I don't know, but I think most of them get out the 26th, so you're getting out about 5 days early. And really, if you finish this over the weekend, you're done, period. So, Caleb, it's up to you. I'm going to email you and Matthew the test on Friday. And I'm going to email your parents and tell them, too, hey, here's when the test is due. Here's when I'm sending the test. Here's what we're doing the rest of the year. Every $20 will raise your grade 5 points. I'm kidding, but I'm going to email them and tell them everything, okay? So there's the info. So you will have a video tomorrow. You will have a video Wednesday. You will have a video Thursday, and I will email the test to you on Friday, okay? Now I'm sorry? 3 videos, yep, and then a test on Friday. And then Caleb, don't forget your test is due Wednesday, okay? I'm going to send you, I'm going to drive it over to your house probably and just give it to you, Caleb. That way I'm done with it, and you have everything. But that's it. I hope you get feeling better. Hope you have a good day. I'll either drive it over or just attach the test to an email. But either way, that's it. And call or email if you have any questions.